Good morning, everyone. In the last session, we completed our discussion related to microservices security by using JWT tokens, right? JWT token is one of the most famous approach in order to secure our applications in the real time. Okay, so how we are going to implement that security in the microservices? I have shared this diagram also. We are having multiple microservices in the backend, greet API, welcome API, auth API, like this. Multiple APIs are available. When user registered, the request will go to auth API. Directly, the request will not come to auth API. The request will come to the API gateway. In the API gateway, we have routings and filters. This filter should be executed for which API we are defining in the routings configuration. Okay. When the request comes to this auth API, directly it will be going to the auth API without executing any filter. If the request comes to the greet API or welcome API, then that filter is going to execute. That filter is basically used to validate the token is valid or not. Okay. So instead of implementing that security in every microservice in the application, we are implementing that security only in the API gateway, which will execute for all the backend APIs. API gateway will act as a entry point for the backend APIs in our microservices architecture. If you have monolithic application, everything, token generation, token validation filter, everything will be available in the single application. But when we are having microservices architecture, token generation is available in one API, token validation logic is available in the API gateway. That token validation required for which backend APIs that we are configuring in the routings. That is what we have done in the yesterday session, and all these APIs code also I have shared in the GitHub repository. All right. Yesterday people asked me about the transaction details in the data JPA. Okay. When we are working with data JPA, guys, transaction management is a inbuilt functionality in the data JPA. So we are using predefined methods in the data JPA in order to communicate with the database. So first of all, what is transaction? First of all, what is transaction? The transaction is nothing but unit amount of work we are going to call as a transaction. What is a transaction? Transaction is nothing but unit amount of work that we are doing is called as a transaction. Suppose, for example, let's take a use case here. In the use case, I want to transfer money from one account to another account. Transfer amount from one account to another account. Transfer money from one account to another account. When we are transferring the money from one account to another account, two operations will happen. So the first operation, deduct money from sender account. Deduct money from sender account, then add the money to receiver account. Okay, add money to receiver account. Okay, so these are the two things that we are doing when we are doing the transfer. For example, Google Pay. So in the Google Pay, you are sending the amount from your account to another account. Then amount will be deducted from your account and amount will be added to receiver account also. Okay, I can also say that debit money from the sender account, then credit money to receiver account. So these are the two operations we are doing. So in the database, we need to minus the amount from the sender account, and in the database, we need to plus the amount to the receiver account. Two operations we are doing. These two operations comes under single unit amount of work. Okay, single unit. These two operations are not separate. These two operations should work as one unit. But here there is a chance of getting the problem. Okay, if the above two operations are completed, if the above two operations got completed, then we will consider that as successful transaction. We will consider that as successful transaction. if above two operations got completed, then we will consider that as successful transaction. If in the above two, if any one operation is failed, if any one operation got failed, then we will consider that as failure transaction. Okay, so I am performing amount transfer. So when I am performing the amount transfer, two things will work here. First thing, we need to debit the money from the sender account, and the same amount we need to add to the receiver account. Two things are happening here. If the above two operations got completed successfully, then we will consider as a successful transaction. So in the above two, if any one operation is failed, then we will consider that as failure transaction, successful transaction and failure transaction. When the transaction is successful, then we need to commit. When transaction is successful, then we have to commit that transaction. When the transaction is successful, we have to commit that transaction. When the transaction is a failure, then we have to roll back the transaction. Okay. If two operations are successful, then we are good. No need to bother about it. If the two operations got completed, then we will consider that as successful transaction. If any one operation is failed, then that is called failure transaction. When the transaction is failure, then we have to roll back the transaction. Okay. Transaction commit will be available and a transaction rollback will be available. Commit means permanently we are going to save the changes in the database. Commit means whatever the operation we have done, we are going to commit the transaction that will be saved permanently in the database. If both operations are successful, then it is successful transaction, then we will commit the transaction. Commit means permanent. If any one operation got failed, then we will consider that as failure transaction. When the transaction is failure, then we have to roll back the transaction. So transaction.rollback we are going to use. Now here in the data JPA, we no need to bother about committing the transaction because we are using predefined methods in the data JPA. So the transaction will be committed automatically when the operation is successful. Suppose if you want to roll back the transaction, then we need to use one annotation for that. So let me take one example to demonstrate on this. Spring Starter project I am taking. Spring Starter project, data JPA, transaction application I am creating. Data JPA, transaction application. Right. Now click on next and MySQL driver. DevTools dependency, data JPA, something like web starter is not required. If you want web starter also, you can take it. Fine. What are the dependencies? DevTools, data JPA, and MySQL driver we are taking to develop this application. Yes. So I'm creating one project now. In this project, I will show you how the transaction will be committed and how to roll back the transaction as well. How to commit the transaction and how to roll back the transaction also we are going to understand. The project is getting created now. Once the project got created, then we need to create some entities and we need to communicate with the database table and we need to perform the operation, and we will see when the transaction is getting committed and when the transaction is not getting committed. How to commit the transaction and how to roll back the transaction. Yeah, project got created. Go to this application. Yes, now here I want to create one entity. I want to create the entity in order to perform operations, right? I'm not using web starter. It is basically a standalone application only, guys. The properties file is available. In the properties file, we are going to configure our data source properties to communicate with the database. So let me take this database username, password and all. Yes, I have configured data source properties. Now I will create some tables in the application. Okay, I mean entities I'm going to create. With the entities, the tables will be created automatically. Yeah, I'm closing the other projects. Application is ready. Now we need to create the entities. So to create the entities, I'm going to use entities package here. 1 minute. Yes. Let me create new class. I'm going to create this inside a package called entity package, and I'm taking the class name as some employee. Employee entity I'm creating. In this entity, I will take some ID, name, salary, some setters and getters. Employee table I'm going to take, and I'm overriding toString method for this. So this is our entity class, guys. Employee entity. Let me import the packages for this. Table, persistence ID and all. So I'm using one annotation called @entity annotation, and I'm using one annotation called @table annotation. Okay. So @ID and @generated value annotations are available. ID, name and salary is available. And we are having toString method also. And we are having toString method also here. Good. ID, name and salary. These are the variables available. Setters, getters. No need to explain anything about that entity class. We already developed so many entities in our application. It is mapped with a table called employee table. Primary key generator is available. Setters, getters for the variable, and toString method is also available. Then next one, I'm creating one more entity with a name called address. Address entity I'm taking. This is also one entity class which is mapped with the database table. Right. As of now, there is no relation between employee and address. These are two different entity classes which are mapped with the two different tables. Right. So let me map with a different table, that is @table annotation I'm using, and I'm specifying name is equal to address table. So employee is mapped to EMP table, address is mapped to address table, address ID is a primary key, generator is available. City, state, country, setters, getters, and if you want, you can generate toString method also for this one. Good. Anyhow, we are not retrieving any data. We will just see how the data is getting inserted and how the transaction is happening here. Source, generate toString method. Click on generate the toString method. Yes, employee entity is available and address entity is available for us. Perfect. So this is our transaction application. This is our transaction application. Two entity classes are available. Now let me create one repository here, guys. .repo package I'm using. One is employee repo, which will extend the properties from JPA repository. And the next one, next interface I'm going to create address repo. One is employee repo, another one is address repo. I want to extend the properties from data JPA. Extends JPA repository. The entity is employee and the primary key is integer type. Primary key is integer type. Coming to the address repository, this is also going to extend the properties from JPA repository. This will also extend the properties from JPA repository and using the entity which is address. Address entity is available and primary key which is a integer. Okay, guys. Employee repository is available and we are having address repository also. We have employee repository and we are having address repository with our entity classes now. Perfect. The next one, I want to perform the operation. I want to insert the records and I want to see how the records are getting inserted. Let me create one service class here, .service. Okay. And I'm using the service with the name called employee service. I'm using a service called employee service. I'm representing this class as a service by using @service annotation. I'm using a annotation called @service annotation. Are you clear with my point? I'm using a annotation which is @service annotation. I want to talk to the repositories here. I'm going to inject employee repository and address repository by using a annotation called auto wiring. So employee repository is available, address repository is available. I'm injecting these beans by using @auto wiring. Now I want to save the employee. Public void save emp. So I will create employee object. I will set some data to the employee and I will save the employee object. So I'm creating employee object. Okay. Setting the name of the employee, setting the salary of the employee. Then I want to save the employee and I want to print that saved employee. We already know in the JPA there is a method called save method is available, which is used to save the employee record. Okay, public void save employee. Employee E is equal to new employee, E dot set name and E dot set salary. Okay, saved employee is equal to employee repository dot save method we are using to save the employee record. And the system.out.println saved employee we are printing on the console. That is fine. Similarly, I'm going to set the address record. I'm creating the address object and I am setting the data for the address object. And I want to save the address also. Employee data will be stored into employee table. Address data will be stored into address table. So do we have any problem in this logic, guys? Is this logic difficult or easy to understand? Is this logic difficult or easy to understand?
Easy.
Easy. Okay, what we have done here? We just created one employee entity. And in that employee entity, we have taken 3 variables and we are generating the setters and getters. Similarly, we have taken one address entity. In that also there are some variables available and employee ID also we are storing in the address. That's fine. And 2 tables, so 2 entity classes are available. Entity is basically used to map with the database table. For every table, one entity class will be available. For every table, one entity class will be available. Fine. Next one. In order to perform operations in the table, I have taken repository. In order to perform operations with the table, I have taken a repository interface, guys. Okay, fine. Employee repository is available and address repository is also available. Employee repository is available and we are having address repository also. Now we are having employee service class. What is the main purpose of this employee service? This employee service is basically used to insert the records into the table. Now let me go to our database. Okay, so SBMS 45 is available. Let me drop everything. Drop database SBMS 45. I will recreate it. Okay, so then I will create database SBMS 45. Show tables. We don't have any tables in the database. Okay, use this database. Use SBMS 45. Now, in our database currently, there are no tables available. It's a brand new database we created just now. No tables available. 2 tables will be created when we run this application. One is employee table, another one is address table. In the employee table, one record will be inserted. In the address table, another record will be inserted. Okay, let me go here and let me execute this application. Start class is available. So it is a standalone application only. Let me take the reference of IOC container, which is context object. Right. Now by using this context dot get bean of employee service dot class. Context dot get bean of employee service dot class. Okay. So we are going to use this employee service bean EMP service bean is available. Then employee service dot save employee. We are calling the method employee service dot save employee method. Now let's observe what is happening here. Run as Spring Boot application. Employee record will be inserted and address record also will be inserted into our database table. Yes, two tables got created, guys. So you can observe that. Address table is created, employee table is created, record inserted into employee table. This is the record employee ID generated and record inserted into address table also. Check the data. Select star from EMP underscore table. Okay, Chari record is inserted. Then select star from address table. Chari address should be there. Yes, Chari address is also inserted. So one method, I am communicating with the two tables, guys. So if you see my employee service here, in single method, there are two operations available. Okay, I'm inserting the record into employee table. With the employee ID, I'm inserting the record into address table. Can we consider this is one single unit amount of work? In one method, I'm communicating with two tables. Can we consider this single unit amount of work, guys? Can we consider this as single unit amount of work?
Yes, sir. Yes, sir. Yes.
Yes. So one record is inserted into employee table, one record is inserted into address table. Now let me truncate these tables data. This is successful transaction, guys. Can we consider this as a successful transaction or this is a failure transaction? Whatever is happening, is it a successful transaction or is it a failure transaction?
Successful transaction.
Successful transaction, because one record is inserted into employee table. Then we got the employee ID. By using that employee ID, we are inserting the record into address table. So employee record is inserted, address record is also inserted. Two queries are executed, two records are inserted into two different tables. So this is successful transaction. But here, am I doing any transaction commit in this process or I'm not doing any transaction commit in this process? Am I
Not
committing
doing,
the
sir.
transaction? I'm not committing the transaction.
Not committing, sir. Not committing.
I am not committing the transaction. Why I am not committing the transaction? In general, so when we talk about the transaction nothing but single unit amount of work. Money should go from one account and money should go to other account. Okay. If two operations are successful, then we will consider that as a successful transaction. When the transaction is successful, then we have to commit that transaction. Whatever the transaction that we are doing, if the transaction is successful, then we have to commit the transaction.commit.
Sir,
If
with
two
the
operations
JPA,
are
with the JPA transaction
if
is by
two
default
operations
enabled, right?
If these two operations are successful, then it is a successful transaction. When the transaction is successful, we have to commit. But here, am I committing the transaction? I am not committing the transaction.
Not committing.
I am not committing the transaction. Why we are not committing the transaction? Because JPA will take care of that.
Okay.
The transaction that we have to commit, when we are using predefined methods in the data JPA, then data JPA will take care of the transaction. Data JPA will take care of the transaction commit. This is positive scenario. Okay. Now let's see the negative scenario. If employee record is inserted, then address also should be inserted. So what is my requirement? These two queries are executing. One query is going to insert the employee record. Another query is going to insert the address record. Currently, both are executed successfully. Two records are inserted successfully. Positive scenario, happy path. Now let's talk about negative scenario. Negative scenario is after inserting the employee record, assume that we are getting some problem. After inserting the employee record, we are getting some problem. Integer I is equal to 10 by 0. Integer I is equal to 10 by 0. What is the meaning of I is equal to 10 by 0?
Arithmetic exception, sir.
Arithmetic.
After employee got inserted, we are getting arithmetic exception. After one record is inserted, then we are going to get the exception. Then the remaining logic will be executed. The remaining logic will not be executed.
Not execute.
The
Will not be
remaining
executed.
will not be
Will not be executed.
But my requirement is if first record is inserted, then second record also should be inserted. If second record is not inserted, then first record also should not be inserted. Simple example. Okay, I am sending the amount from one account to another account. So this is my sender account and this is my receiver account. Okay, so this is sender, and this is receiver. Okay, so one person sending the amount from one account to another account, bank transaction, sender and receiver. In the sender account, currently the balance is equal to 10,000 rupees. Balance is 10,000 rupees. In the receiver account, currently balance is equal to 500 rupees available. Sender account is having 10,000 rupees balance and receiver account is having 500 rupees as a balance. Are you able to follow me?
Yes, sir.
Are you able to follow me? Sender balance is 10,000, receiver balance is 500. Now I want to send the amount from sender account to receiver account. I want to send the amount from sender account to receiver account. How much amount I am sending? Sending 2,000 rupees. I'm sending 2,000 rupees. When I'm sending the 2,000 rupees here, deduct 2,000. Deduct 2,000. When it is deducted 2,000, then balance is equal to 8,000 here. 2,000 we are sending. Amount is deducted. But after deducting the amount, while sending the amount, we got the exception. Amount is not added here. So two operations. You need to minus the balance from the sender account. And you need to add the balance to the receiver account. Two operations. Deduct amount from the sender account and add the amount to the receiver account. Two operations. But what happened? After one operation is executed successfully, we got the exception. Amount is deducted from the sender account, but amount is not added to the receiver account. One operation is a success, second operation is failed. One query executed successfully, second query not executed successfully. So this is failure transaction. Whenever the transaction is failed, what should happen? If amount is deducted from the sender, then that amount should be added to the receiver also. If amount is not added to the receiver, amount should not be deducted from the sender. That is what we are expecting. If amount is going from my account, amount should come to your account. If amount is not coming to your account, then amount should not go from my account. That is called atomicity. Either both operations should be successful or no operation should be successful. When we are dealing with the transaction, we need to achieve a concept called atomicity. What is the meaning of atomicity? You can just Google here. What is atomicity? In the acid properties, atomicity concept is available. What is atomicity in the DBMS? Atomicity in DBMS. Okay, in the database management, atomicity ensures that all the commands in the single transaction treated as single unit and either succeed or fail together. That means partial transaction should not happen. Either all the operations should be successful or no operations should be successful. Then we are going to consider that as a atomicity. So when we are performing the operation, either all the operations should be successful or no operation should be successful. If amount is going from sender account, then amount should come to receiver account. If amount is not coming to the receiver account, then amount should not go from the sender account. Are you clear?
Yes, sir.
Are you clear with my point now? Yes, the same thing here also. If employee is inserted, then address also should be inserted. If address is not inserted, employee also should not be inserted. Either two records should be inserted or no record should be inserted. That is the atomicity I am expecting. Are you guys getting my point? Are you guys getting my point? Yes, now are we able to achieve the, suppose if I don't have any problem, the two records are inserted as expected. Address record is inserted, employee table, address record is inserted, address table, address is also inserted. Employee inserted, address also inserted. Currently we don't have any problem. Now let me truncate the table, employee table and address table. I'm truncating now. Okay, now see the employee table, no record available. See the address table, no record is available. Now let me create some problem in the program. Integer I is equal to 10 by 0. So after employee record is inserted in the database, I'm getting a problem. When the problem occurred, the remaining logic will not be executed. So employee record will be inserted, address record will not be inserted. There is no atomicity. My requirement, either both records should be inserted or no record should be inserted. Let's try this. Run as boot application. I'm running the Spring Boot application now and check the behavior. I'm running the Spring Boot application, check the behavior. Now can you see? Inserted to employee table, employee record is inserted, then we got the arithmetic exception. Employee record is inserted, then we got the arithmetic exception. Are you clear with my point? The record is inserted into employee table, then after that we got the exception. Now go here, employee table, select a star from employee table. Can you see? One record is inserted into employee table, then go for address table. Record is available in the address table. The record is not available in the address table.
Not available.
Not available.
So here, two operations are successful or only one operation got successful?
Only one
One operation got
operation.
successful.
Two operations got success or only one operation got success?
Only one operation.
Only one operation got success. So are we able to achieve atomicity or we are not able to achieve atomicity? First of all, what is atomicity?
All the operations should be complete.
Either all or none. The meaning of atomicity is either all or none. If first record is inserted, if employee inserted, then address also should insert. If address is not inserted, then employee also should not insert. Are you getting my point? So here, what is happening in the data JPA? Whenever you call the save method in the data JPA, the transaction will be auto committed. Whenever you call the save method, then the transaction will be auto committed in the data JPA. Are you able to follow me?
Yes, sir. Yes, definitely.
So whenever you call the save method, then the transaction will be auto committed in the data JPA. So first time when we call the repository.save of employee, the employee record is inserted in the database table, then the transaction is committed. Saving employee and transaction commit. Okay. Spring Boot data JPA don't know that there is a problem in the next line. So that's why when the employee is saved, the transaction is committed automatically. After this, the exception occurred. Then the remaining logic is not executed. So already transaction committed, employee is saved permanently in the database. But now I want to change this requirement. If employee inserted, then I want address also to insert. If address not inserted, my employee also should not insert. Are you able to follow me? I need to tell to the data JPA, boss, you are committing the transaction here. You are committing the transaction here. Don't do that. Don't do that. Okay. If these two methods are executed successfully, then only you commit the transaction. If these two methods are not executed successfully, if these two operations are executed successfully, then only you commit the transaction. If these two methods are not executed successfully, don't commit the transaction. How to inform that? To inform that to the data JPA, we are going to use a annotation called @transactional annotation is available. @transactional annotation, I will specify rollback on. Rollback on is equal to exception.class. Rollback on is equal to exception.class. Now let us go to employee table, truncate it. I'm deleting the old record. Select star from employee table, then select star from address table. So do we have any data in the employee table and address table?
No, sir, no data.
The both tables are empty now. Both tables are empty now. Okay, if you see employee table empty, and if you see address table, this is also empty. Okay, so then what we are doing, I have a method. Earlier this annotation is not available. Then employee saved, address is not saved. No atomicity. If both, either both should be success or nothing should be success. So for this we are using @transactional rollback is equal to exception.class. So what is the meaning of rollback is equal to exception.class? I'm telling to the data JPA, boss, this is my single unit amount of work. If both operations are success, then only you commit. If you face any exception in the method, then you roll back the transaction. So if address is not inserted, employee also should not be inserted. So in the interview, they may ask a question, how to roll back the transactions in the data JPA. Transaction commit is not our duty. So data JPA will take care of committing the transaction. Whenever you perform save or delete operation, transaction will be auto committed. So if you want to roll back the transaction in the data JPA, then this is the option we have. @transactional rollback is equal to exception.class. That means whenever exception occur in this method, then immediately that transaction will be rolled back. Guys, observe the code. Yeah.
Yes, sir. Hello.
Voice is breaking, sir.
Hello, sir. Hello.
Yeah, hi.
Hello, sir. Sir, when you are sending the money to another account, sometimes payment, they are doing a processing payment, sir.
There is a background noise from your side, sir.
Okay.
Okay, fine. So @transactional annotation is available. Rollback is equal to exception.class. Rollback on exception.class. Whenever exception occur in this method, so whatever the employee record is getting inserted now, whenever the exception occurred, that should be rollback. So if problem is available, both records should not be inserted. Now try this. My employee table is empty and my address table is also empty. Now let me run this application. Run as boot application. Go to the console. Now there is an exception. Okay. Now go to database. Address record is not inserted. Employee table. Employee inserted or not inserted now?
Not interested.
Not inserted, sir.
Earlier what happened?
Inserted, sir.
Inserted, sir, inserted.
Earlier employee inserted but address not inserted. But now both are not inserted. If there is a
Hello,
problem,
sir.
if there is a problem, transaction will be rolled back. Okay.
Sir,
Trying
where
to
I can
Hello,
change the
sir.
rollback query in the log.
Hello, sir.
It is trying to insert the employee record. Okay, the query got executed, but as the problem occurred in the method, immediately the transaction got rolled back. Query will be executed because we are calling the save method. We are calling the save method. The employee record should be inserted. The record will be inserted in the database. But whenever the problem occurred, immediately whatever the query is inserted, whatever the query is executed, whatever the record is inserted, that record will be rolled back from the database. That is the main purpose of rollback. First, employee record will be inserted in the table, but it will not be committed that. It will not commit that. So if there is no problem, then the transaction will be committed. If there is a problem, then immediately it will roll back. So that is the reason in the database, we are not able to see the employee record because the rollback is happened. That's why the record is removed from the database. You got the
Hello,
class?
sir. Hello,
Yes.
sir. But sometime money deducted from our account, but not added in another account, and they will say us ki your money added in your account within the 24 hours, 48 hours, like this, sir. What happened with that time?
That is a batch processing, sir. In general, whenever you go for the NEFT transaction, so in the bank operations, two types of processing will be available. NEFT processing will be available, IMPS processing will be available. When you send the amount by using IMPS, immediately it will be added to their account. When you send the NEFT transaction, they will execute that like a batch processing. How they will execute processing?
How, sir, that money if deducted from our account, then how can they add in our account only, sir?
Sir, let me tell you. So in the real time, whenever you go for the next transaction, there will be a concept called batch process. Okay. So every day, the batch process, suppose customers are sending the amount. Customers are sending the amount by using the NEFT transactions. So what they will do, the amount that you are sending will be added to a batch process. That batch process will have a schedule. Every day morning, 9 a.m. batch will execute, 11 a.m. batch will execute, 1 p.m. batch will execute, 4 p.m. batch will execute, some 6 p.m. batch will execute, like this. For every 2 hours, whenever you send the amount by using NEFT transaction, immediately it will not happen. Whatever the amount you are sending, that will go to the batch job, and the batch will have a schedule. Whatever the transaction happened, after 2 hours, your amount will be added. In the next batch, your amount will be picked up. Whenever you send the amount after 9 o'clock, then our amount will go to the receiver by using second batch schedule at the 11 a.m. Any transaction happened after 11, it will be added to the batch. It will go at 1 p.m. Like this, batch processing will be implemented. The scheduled jobs will be executed. This is only for the NEFT transaction. Suppose, for example, whenever you go for IMPS, the IMPS means sender amount will go to the receiver account immediately. IMPS extra charges will be available. So where IMPS for every 1 lakh or for every 1,000, the charges 5 rupees, 10 rupees extra charge will be applicable, and they will send the amount immediately to the receiver. But when you go for NEFT transaction, for every 2 hours, the batch will execute. All the transactions happen at 9 o'clock will be added to batch, and they will execute at 11 a.m. So 9 to 11, whatever the transactions happen, those transactions will be going in the next batch schedule at the 1 p.m. So 11 to 1, whatever the transactions happen, they will go in the next schedule. Like that, they will add the batch, and batch will execute in the fixed intervals. For every 2 hours, batch job will execute. That batch job will process NEFT transactions. And one more scenario, you are sending your amount to the receiver. So there is some problem. They will say that there is a problem. To process your transfer, it will take another 24 hours to process your transaction. Then what will happen? Whenever the amount is going to the receiver, if there is a failure, whatever the failure transactions are available, the failure transactions will be added to the message queue like a Kafka. Whatever the transaction is failed, the transactions will be added to the message queue like a Kafka. Whatever the transactions added to the Kafka queue, at the end of the day, they will read the messages, they will read the transactions which are failure, and those transactions they are going to reprocess. Retry mechanism we are going to implement. That retry mechanism is used to reprocess the transactions which are failed. Those retry mechanism will execute every day night at the 9 p.m. or 10 p.m. they will try to reprocess the transactions which are failed. Message queue concept will be implemented. Sender is sending the amount to the receiver. Suppose the transaction got failed. Whatever the transaction which is failed transactions will be added to one queue to understand which transactions are failed. Whatever the failed transactions are available in the queue, we will read all the failed transactions and we will try to reprocess them. Whenever we retry, if it is successful, okay. If it is failure, your amount will come back to your account within 24 hours of time. Retry mechanism will be implemented for that.
Sir, who will write into that queue, sir? If it is a failed transaction.
Project, sir. Right. So here, whatever the operation that we are doing, so here assume that this logic is to deduct the amount from one account, and this logic is to send the amount to the another account. Whenever there is a problem here, whatever the transaction is failed, we will write a logic to store that message to the Kafka topic. We have seen what is Kafka, how to write a message to Kafka.
Handle exception here in the there
Yes.
we will write it.
Yes, we will handle the exception by using try catch block, and whenever the exception occurred, immediately we will send the transaction details to the Kafka topic. Whatever the messages are stored in the Kafka topic, we will read those messages, and within 24 hours we will try to reprocess them. In the reprocess, again some transactions, suppose assume that today 100 transactions are failed. 100 transactions are failed. So the failed transactions are available in the Kafka topic. We will read the messages from the Kafka topic and we will retry them. Whenever we retry, out of the 100, 70 got passed. 70 got passed. In the retry, they got successful. Okay, 30 failed. Whatever the 30 transactions are failed, then we will roll back. 30 transactions failed, nothing but for them, amount should be sent back to their account. Suppose simple, in the Google Pay, whenever you send amount, sometimes transaction will fail. They will say the transaction is in progress. That means they will retry your transaction after some time. In the retry, if it is successful, status will be confirmed. In the retry also, if it is failed, then it is a failure. Then they will send amount back to your account. That is banking processing that people will follow.
So retrying also just like a scheduler, sir. Retrying also scheduler.
Retry is like a scheduling. Retry, they will retry is a design pattern. Basically, we will implement that.
Okay, sir.
Okay.
And the same thing, retry only send the money back to the sender, sir, again.
Yes.
The
Retry, if it is successful, that is okay. If it is failure, they will send money back to the sender account. Good. Are you able to understand what is rollback transaction, guys? So here, single unit amount of work is called as a transaction. So two operations are executing as a single unit. If two operations are successful, then it is a successful transaction. If the transaction is successful, then we are going to commit the transaction. If any one operation got failed, then we will consider that as a failure transaction. When the transaction is failed, then we have to roll back the transaction. In the data JPA, commit is not our duty. Data JPA will take care of the transaction commit if everything is successful. If there is any failure, then it is our responsibility to specify in the rollback, how to specify the rollback. So in one method, I'm communicating with two tables. I'm trying to insert two records. If two records are successful, commit. If any record is failed, then rollback. If exception occurred, after inserting the employee, if exception occurred, then employee will be rolled back from the database. Employee also will not be there in the database. Suppose if there is no exception, then rollback will not applicable. Both records will be inserted into database. Currently, in my database, employee table, there is no data. And in the address table also, there is no data. Okay, let me run this application. Now record should be inserted. Successful transaction. Two records should be inserted in the database because there is no problem. You can see employee is inserted, address is also inserted. Select star from employee table and select star from address table. The records are not inserted into database table. Records are inserted into database because there is no problem. Rollback is not working because it is a successful transaction. Suppose if there is a problem, then it is a failure, then the rollback will happen.
Sir, transaction we have to use with the session.
Not required, sir. Why session? Transaction is different, session is different. Session is basically used to remember user data. And one more thing, as we are developing backend microservices, nothing but REST APIs. REST API is a stateful application. REST API will not remember anything. REST API is completely stateless. Every request will consider as a fresh request. Every request it will consider as a first request only. No need of session in the microservice. We don't use session in the microservices. If you want to remember user data and all, the session will be handled at the front end, not at the back end. Earlier, when people used to develop the monolithic application, people used to implement session concept. But when it comes to the microservices, that session concept is not required in the backend. So session will be, because if you manage the session in the backend, it will increase burden on the server, because backend will execute in one server. For every user, if we create one session, the burden will be increased on the server. That's why nowadays people are not using session in the backend. Session will be used in the front end. That front end session will be created in the browser. So for every user, their own browser, the burden will not be there on the application. So front end sessions are recommended when compared with the backend session. That's why in the microservices, backend APIs, session concept will not be available.
Okay, sir. So on the line number 21, so it is applicable for the all kind of exception, right?
Any type of exception. It is a super class, right? Whether it is arithmetic, whether it is a null pointer, whether it is a typecast, whether it is any type of exception. Whenever any exception occurred, then the transaction will be rolled back.
Okay, sir.
Sir, any other use case, sir? Transaction annotation?
No, sir. This is the annotation we need to use for the transaction management in the JPA. No other annotation.
Okay. Any use case, sir? Any transaction?
Sorry?
Annotation? Only one. This kind of purpose only you can use the annotation, sir.
Yes, correct.
Okay.
Sir, one doubt. Sir, in production, it's already tested application like we are testing, and after UAT testing, we are pushing to production. And if application is running, why a transaction is failing in the meeting, in the mid, like some transaction are failing?
Sir, code we have written, that code is tested, that code is working here. But why
Yes.
it will fail in the real time, why it will fail in the production means, it can be n number of reasons. It can be a data exception. Sometimes whatever the data we are expecting, the data is not coming, null point exception can occur. And whenever we are inserting the employee record, there is a chance that foreign key constraint is failed or unique constraint is failed. Maybe the database server is down. Our query is not executed, or the network is down, and the memory issue is occurred. N number of reasons.
Okay, sir, got it. Yes, sir. Thank you, sir.
Yeah, simple example. My application is communicating with the database to insert the record.
Yes.
Got it. So here, assume that this is my Spring Boot application. I'm trying to insert a record into database. So we are using two databases in the. We are using a database. We are trying to insert the record into the database. This is my DB. Okay. So I'm inserting employee record into the database. So when I inserted employee record, that is okay, successful. When I'm trying to insert the record into the address table, at that time, in this fraction of millisecond, my database connection got timed out. It is failed.
Okay.
It's not because of code problem, maybe database problem, or maybe network problem, maybe memory problem, maybe some other issue, maybe thread got stuck. Reason
Yes.
can be anything.
Correct, sir.
Okay.
Yeah, got it.
Yeah. And one more thing, guys. So this is the transaction rollback we are doing. Both tables are available in the same database, right? Both tables are available in the same database. Employee table is available and address table is available. Both tables are available in the same database. So whenever exception occurred, we are able to roll back the transaction. Whenever exception occurred, we are able to roll back the transaction. For example, if the tables are available in the two different databases, this is the database 1 and this is the database 2. So here we are inserting the record, here we are inserting the record. This is DB1 and this is DB2, two databases. And I am writing one method which is used to insert the record. So here M1 method is available, which is used to insert that record. And here we are having M2 method, which is used to insert the record. This M1 method and M2 method, both methods we are calling from another method called M method. M method is calling M1 and M2. M1 is inserting the record into first database, M2 inserting the record into second database. So this is something like Oracle database. Okay, this is something like Oracle database, and this is something like a MySQL database. There is no relation. One is Oracle DB, another one is MySQL DB. To insert the record into Oracle database, we are using M1 method. To insert the record into MySQL database, we are using M2 method. So these two methods we are calling from another method called M method. Now M1 is executed successfully, but M2 is failed. Then what we need to do? How do you handle this scenario? This is one scenario. And second scenario, there is one microservice is available and another microservice is available. Okay, so this is order API and this is payment API. Order API, payment API. Order API is communicating with one database. Payment API is communicating with another database. This is DB per service. Okay, in the real time. This is DB per service. Now, whenever the order is received, it is inserting the order into database. Then, as the order is talking to payment API, it is communicating with another database. So, customer is placing the order. Customer is placing the order, then order is created in the database table. Order is created in the database table. Then, after the order is created, then the request is going for the payment processing. But in the payment processing, it is failed. Okay, if the payment is failed, then what about the order we created? Order is one microservice, payment is one microservice. Order
Yes, sir,
API is created, order API got the request to place the order is placed, order is inserted in the database table. Then after the order, inter-service communication, it is communicating with the payment API. So payment processing is happening, but payment is failed. Payment is failed. These are two different microservices talking to two different databases. How do you handle this scenario? This is called distributed transaction management, guys. Okay, when you are dealing with the microservices, one microservice is communicating with the another microservice, but in that communication, the order is created. Order is created. After the order, the request is going to the payment, but the payment is failed. Then what about your order? You placed order, you went to the you landed on the payment page, but your payment is failed. Then you need to roll back the order. But both are two different microservices talking to two different databases. So that's where distributed transaction management comes into picture. How do you handle the distributed transaction management, guys? To handle distributed transaction management, we are going to use one design pattern called Saga design pattern. What is the design pattern we will use to handle the distributed transactions, guys? To handle distributed transactions, we are going to use Saga design pattern. When you want to deal with the transactions, when two microservices are communicating, then we will implement that by using Saga design pattern. So the Saga design pattern implementation videos I have already shared in the group. So today, please go through those two videos. They are very, 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 very important for the interview. What is the distributed transaction management? How we will handle the distributed transactions in the microservices by using Saga design pattern that I have shared already in our WhatsApp group.
Sir, can you share the Docker one also?
Docker yesterday class attended. You people attended live class?
Yes, sir.
No,
No, sir.
Yesterday 6 p.m. we conducted the Docker live class. Did you guys attended that? We
sir,
Sir,
it
I
is
give the link 5 days, sir. After
yesterday
completing the.
I informed you people to attend the Docker class at 6 p.m.
Yes,
You
sir, I
attended?
attend, sir.
Sir,
Yes,
it
sir,
is free, right? This
Yeah, it is free, sir. Today, yesterday, today, tomorrow. 3 days you can attend the Docker. So Docker will be completed for us. You will get the videos also in the YouTube.
okay, sir.
So
Okay.
today, please, today is very important for the Docker guys. Yesterday, just we completed the introduction of Docker. Today, I will explain how to set up the Docker and how to work with the Docker. Today, please don't miss the class at 6 p.m. You will understand what is Docker.
Sir, Kafka, you take the class is enough, sir. Go for
Sorry?
interviews. Kafka,
Huh.
you take the class, sir, is enough, sir. We go for interviews.
Kafka I have explained in the class.
Yes, sir, is enough, sir. You attend the
Yes, that
interview.
is enough for the developers. Sir. I have explained what is Kafka, how to set up Kafka in our local, how to publish a message to the Kafka, how to read the messages from the Kafka. I have explained. For the developers, that is sufficient.
Okay, sir. Okay. Thank you.
Sir, in
Whatever the Kafka, I
associations,
have explained that, sir. Okay?
sir, in
Yeah.
associations,
Fine. I want you people to go through the Saga design pattern videos, guys. That Saga design pattern is very, very, very important for the interviews. I have shared the videos in the YouTube. And I have given the links also in our WhatsApp group. Saga videos I have given, Docker videos I have given, AWS RDS videos I have given, Spring Boot Excel report generation video I have given, 100 Spring Boot interview questions I have given. Okay, Docker anyhow, yesterday live class happened. Today and tomorrow also you can attend the Docker class at 6 p.m. Today we will discuss about Docker setup and Dockerization of our applications. We will discuss in the today's session. Okay, fine. You understand what is the transactional rollback concept here? What is the purpose of transactional rollback?
Yes, sir. Yes.
Yes. What is the purpose of transactional rollback here? What is the purpose of transactional rollback here, guys?
To implement atomicity in our
Which is used to achieve atomicity in our transaction management. So whenever the first record is inserted, then second record also should be inserted. If the second record is failed, then first record also should not be inserted. That's where we are going for transactional rollback. If exception occurred, then it will roll back. If exception not occurred, then it will commit the transaction. Okay. Now currently there is only one method is available. Within one method, we are trying to perform two operations. But when we are working in the real time, assume that there is M1 method is available. There is M1 method is available and it is trying to communicate with the database. It is trying to perform some operation and there is another method called M2 method is also available. M1 is available and M2 is available. M1 is available and M2 methods are available. So this M1 method and M2 method both are communicating with the database, guys. M1 method and M2 method, both methods are communicating with the database, same database only, right? M1 is trying to insert some records into database. M2 is also trying to insert into database. And this M1 method is calling the M2 method. We are calling the M1 method and this M1 method is trying to do some operation and it is calling the M2 method. M2 method also trying to perform some operation with the database. So who is calling method? Who is called method here? M1 calling M2. So now can you tell me which is calling method and which is called method?
M1 is called.
M1
is calling.
M2 is called.
Yes, this is called as
M1 is
calling. This is called as a calling method. M1 is calling M2. M1 is calling M2 and this is called as called
called
method.
method.
Called method. M1 calling M2 and M2 is called as a called method. So whenever we have this kind of scenario, whenever we have this kind of scenario, then how we need to handle that transaction? How we need to handle the transaction? So when we are having, suppose here in our scenario, only one method is available. In one method, we are inserting employee and we are inserting address. If there is no problem, transaction will be successful, transaction will be committed. Suppose if there is any problem, then the transaction will be rollback. Okay, this is straightforward single method. But when we go for the project implementation, two methods are available. M1 is M2. M1 is calling M2. Both are talking to the database. So when we have this kind of communication, this kind of requirement, then how we will manage the transaction? Okay, if you want to maintain data integrity and data consistency, when you have this kind of scenario, then we need to use a concept called, whenever we are having this kind of requirement, guys, when we have this kind of requirement, then two important concepts we need to understand. One is transaction propagation. When you have this scenario, so if you have only one method like this, then no problem. Suppose if you have this kind of scenario, then we need to talk about transaction propagation and we need to talk about transaction isolation. Okay. When one method is talking to another method, in order to perform the DB operations, if you want to maintain the data consistency, data integrity, then in the transactions, we need to use a concept called transaction propagation concept and transaction isolation concept will be available. Transaction propagation and transaction isolation. Okay. So what is the meaning of this transaction propagation? When you talk about the transaction propagation, how the transaction will be related from M1 method to M2 method. M1 method is having a transaction. Then same transaction should be used by M2 method, or new transaction is required for the M2 method, that will be decided by transaction propagation. That means, do you want to reuse single transaction for multiple methods, or do you want to create a new transaction for every method? That will be decided by transaction propagation. Propagation means forward. So here my calling method is having a transaction. So same transaction is required for M2, or do you want to create a new transaction for M2? That will be decided by transaction propagation concept. Transaction propagation concept. Then what is transaction isolation? Transaction isolation will define that whatever the operation done by M1 method in the database, that operation is visible for M2 method or not in the database is decided by transaction isolation. One transaction, whatever the operation happened in one transaction, that operation should reflect for the other transaction or not will be decided by transaction isolation concept. Basically, acid properties, atomicity, consistency, isolation, durability will be available in the DBMS. Atomicity means we understood. If whenever we are performing operation, either all operations should be successful or no operation should be successful. So if you want to achieve the atomicity, then we are using transactional rollback concept. Okay, transaction propagation and transaction isolation. So what is the meaning of propagation? Propagation will differentiate that. Propagation will define how transactions are related to each other. Okay. So how transaction is related between calling method and called method. Transaction propagation defines how transaction is related between calling and called methods. So M1 is calling M2. How the transaction is related between the M1 method and M2 method will be defined by our transaction propagation. Transaction propagation is used to define how the transaction is related between calling methods and called methods. Calling methods and called methods. And the next one here, transaction isolation. Transaction isolation defines the changes made by one transaction visible to another transaction or not. Okay, defines how one transaction changes visible to another transaction. Transaction isolation defines how and when how and when changes made by one transaction visible to another transaction. Transaction propagation defines how transaction is related between calling and called methods. Transaction isolation defines how and when changes made by one transaction visible to another transaction. When this concept is required, when you are having this scenario, one method is calling another method, then only the propagation and isolation is required. So if you are using a single method to perform the operation, then atomicity is required. Are you able to understand what is the meaning of transaction propagation and transaction isolation? Could you please understand what is the meaning of transaction propagation and transaction isolation, guys? Come on. Transaction propagation and transaction isolation. What is the purpose of these two? Could you please read it?
To identify the same transaction would be applicable for all the method here now. Or else we have to create the new transaction.
Yeah, guys, you understand what is the meaning of a propagation and what is the meaning of isolation? Transaction propagation. What is the meaning of transaction propagation here? How transaction is related between calling method and called method, that will be represented by propagation. Transaction propagation defines how transaction is related between calling and called methods. So as I told you, M1 method is available. That M1 method is calling M2 method. M1 is calling M2. Then when we are having this scenario, how the transaction is defined, the relation between calling method and called method. And the next one, transaction isolation. So what is the meaning of the transaction isolation? Transaction isolation will define when and what changes are visible to the another transaction. Transaction isolation defines how and when changes made by one transaction is visible to another transaction. Okay, when we are having a scenario, when one method is calling another method, then how the transaction is related between these two methods will be defined by propagation. Isolation, the changes made by one transaction, how and when is visible to another transaction will be defined by isolation. Okay, good. So here, when we are talking about transaction propagation, guys, so we are going to specify here propagation, exception rule, transactional, rollback on exception, at the rate transactional annotation, it will read some properties. So propagation rollback on value is available at the rate transaction. Spring framework transactional is available. In this transaction, we are going to specify propagation. Okay. At the rate transactional, Spring framework transactional annotation. At the rate, sorry, not this. At the rate transactional Spring framework transaction, and we can specify propagation is equal to. So these are the options that we can give for the propagation, guys. So required, requires new, not supported, never, nested, mandatory, supports, like this there are several options available. The default option for transaction propagation is required. So what is the meaning of required? Okay, required means if calling method already having a transaction, then use the same transaction for the called method also. That means if M1 method is having a transaction, then use the same transaction for the M2. If the transaction not available, then only create the new transaction. That is the default to propagation, guys. When you go for the default to propagation, required is available. It is a default. So if M1 is having transaction, then use same transaction for M2. If not, create a new one. So whenever we use at the rate transactional, propagation level, by default it is required. By default it is required. So what is the meaning of this? Here, assume that I'm having M1 method, public void M1 method is available, and I'm having public void M2 method. Okay, M1 method is calling M2 method. M1 method is calling the M2 method. Then when I specify at the rate transactional at the M1, okay, and at the rate transactional at the M2. So here I'm going to specify at the rate transactional propagation is equal to required. Right. So that means M1 is already having the transaction. Then use the same transaction for M2 because M2 is called by M1. So that is required propagation. Propagation level is required. That is the default. If you don't specify this also, no problem because the default propagation level is required. If a calling method is already having a transaction, then use the same transaction for the called method also. That is propagation required. If you don't specify required also, no problem because the default is required only. So transaction propagation. When you go for transaction propagation, guys, one method is calling another method. When one method is calling another method, then how the relation is there between these two methods, calling method and called method. Okay, so required, default. If a transaction exists, use it. If not, create new one. If M1 method is calling M2 method, M1 method is having a transaction, then use the same transaction for M2. If the M1 method transaction is not available, then for the M2 method, new transaction will be created. So you understand what is propagation level required, guys? You understand what is the propagation required in the transaction? When you have calling method and called method, how the transaction is having a relation between the calling method and called method? Required propagation. If a transaction available with the calling, use the same thing for called. If a transaction exists in calling method, then use it for called method also. If not available, then create new transaction for called method. That is the meaning of required propagation. Okay. And there is another propagation is available. Requires new propagation is available. Requires new propagation. Instead of giving propagation as required, you can give the propagation as requires new. Propagation requires new. Always create a new transaction. Suspend the current transaction if exists. Okay, this is required. And here I'm going to specify @propagation. Propagation is equal to requires new. So called method is having a transaction, but for the calling method is having a transaction, but for the called method requires new. So remove previous transaction and always create a new transaction. That is the propagation requires new. Always create a new transaction and suspend the current transaction if it is exist. Okay, required means use it if it is already available. Requires new, always create a new transaction. The next one, there is an option called supports. There is an option called supports. What is the meaning of supports? If a transaction exists, use it. If the transaction not available, execute without transaction. Supports means if transaction exists, use it. If not, execute non-transactionally. Okay, and there is an option called not supported. Option called not supported. Not supported means always execute without a transaction. If any transaction available, also then you delete it. Required. If transaction exists in the calling method, then use it for called method also. If not available, then create new transaction for called method. Requires new. Always create a new transaction. Suspend the current transaction if one exists. If anything is available, delete it and create a new always. Requires new always. Supports. If a transaction exists, use it. If not, execute non-transactional. Try to execute the method without transaction. If available, use it. If not available, try to execute without transaction. Not supported. Always execute non-transactionally. Suspend if any transaction available also. Okay. Now, there is an option called mandatory. Propagation mandatory. So you can specify propagation dot mandatory. When you specify propagation mandatory, what is the meaning? Always a transaction is required from the calling method. If a calling method does not have a transaction, it will fail. Requires an existing transaction. It will not create the new transaction. If the existing transaction is available, then only it will execute. If the existing transaction not available, then it will give the exception. That is mandatory. And there is another property which is never. Okay. There is another property available which is never. What is the meaning of this never propagation? Never. See here, execute non-transactionally, throw an exception if transaction exists. Okay. Never means execute non-transactionally, throw an exception if transaction exists. So if there is no transaction, then only it will execute. If the transaction available, it will fail. And there is another propagation is available, which is called a nested. What is the meaning of a nested propagation? You can see here. Execute within the nested transaction if the current transaction is available. Otherwise, there is no features. Otherwise, behave like required. Otherwise, behave like a required. Nested. Execute within the nested transaction if current transaction exists. Otherwise, behave like required otherwise. Execute within the nested transaction if a current transaction available. Behave like required otherwise. That means if the transaction is available, execute. If the transaction is not available, create new. Nested. These are the propagation levels of the transaction. So transaction propagation defines how transaction is related between calling and called methods. In below scenario, in below example, M1 is calling M2. M1 is calling M2. So M1 is calling method and M2 is called method. M1 is a calling method, M2 is a called method. So how the transaction we need to represent between M1 and M2? For that, transaction propagation is available. So we have several propagation levels in the transaction. Required, requires new, supports, not supported, mandatory, never, nested. These all are the transaction propagation types we have in the Spring Transaction Management. What is the meaning of required? It is the default. If you don't specify anything, by default, the transaction propagation comes as required. If your transaction exists in the calling method, use it for the called method. If not available, then create new transaction for the called method. Requires new. Always create a new transaction. Suspend the current transaction if anything is available. Supports. If transaction exists, use it. If not exist, execute non-transactionally. Not supported. If transaction available, suspend it. Always execute non-transactionally. Okay. Mandatory. Requires existing transaction. If not available, throw the error. Never. So if transaction available, it will give the error. It will always execute without transaction. Nested. Execute within the nested transaction. If a current transaction exists, behave like required otherwise. Okay, this is transaction propagation level. So based on the requirement, we can specify any propagation level that we have, and that too when you have this scenario, then only these propagation levels are required. Okay, if you have a single method, it's not required. When we have calling method and called method, then transaction propagation we need to specify. The next one, transaction isolation. What is the meaning of transaction isolation? Transaction isolation defines how and when changes made by one transaction visible to another transaction. Okay, so here the transaction levels, main propagation types we have seen, and here are the transaction types. Below are the main propagation types. Below are the main propagation types. So isolation. So M1 method inserted one record into database. Whether M2 methods can access that record or not from the database. Whether M2 can see the record in the database or not. Defined by transaction isolation. M1 method inserted one record into database. Is that record visible for M2 or not? Can M2 read the record from the database or not? Defined by isolation. So if you see, transaction isolation defines how and when changes made by one transaction visible to another transaction are not. Okay, so the main levels of isolation in the JPA. What are the isolation levels available in the JPA? Let's understand. Okay, how we are specifying the propagation? Similarly, we can specify isolation also. Isolation types: default, read committed, read uncommitted, repeatable read, serializable read. Like this, we are having 4 isolation levels here. 4 isolation levels are available when you go for this transaction isolation. So that means M1 inserted one record into database, and when that record is visible for M2, it is defined by isolation. Okay, what are the isolation levels are available in the JPA? The isolation levels, first one is read committed. There is a isolation level called read committed. What is the meaning of read committed? Whatever the transaction which is committed by the M1, only that data can be read by M2. If M1 commit the transaction, then only M2 can read the transaction. It will allow the dirty reads. Okay, so it will prevent the dirty reads. Read committed. Okay, stop, prevent dirty reads. That means we should not read uncommitted data. Prevent dirty reads. Prevent dirty reads. Transaction can only read the committed data. Transaction can read only committed data. If M1 is committing the data, committed the data, then only M2 can read. Okay, so I will specify isolation is equal to read committed. Okay, if M1 committed that data, then only M2 can read that data. That is isolation read committed. That is isolation which is used to read the committed data. And similarly, we are having read uncommitted also. There is an option called read uncommitted. Okay, read uncommitted means allow dirty reads. Allow dirty reads. Transaction can read uncommitted changes also from the other transaction. Transaction can read uncommitted changes also from other transaction. M1 inserted a record but not committed. But still M2 can read uncommitted data. That is a dirty read. Dirty read means transaction not committed, we are reading. After some time, if they roll back, whatever the data you are reading, it is a dirty data. It will not be available in the database. M1 inserted employee record. We have seen. So M1 method inserting employee record, but not committed as of now. By that time, M2 reading the data. After M2 reading the data, there is an exception in the M1. Then that will be rolled back. That is a dirty data. So if you want to read the dirty data, then you can use read uncommitted. Read committed means prevent dirty reads. Transaction can read only committed data. Read uncommitted means allow the dirty reads. Transaction can read uncommitted changes also from the other transaction, which is not recommended, guys. Always we should read the committed data. We should not read the uncommitted data. Are you clear? Repeatable read. Repeatable read. There is other option. Repeatable read. And there is the other option. Serializable. Isolation. Serializable. Okay. Transaction isolation levels. Transaction isolation defines how and when changes made by one transaction is visible to another transaction. Read committed, read uncommitted, repeatable read, and serializable is available. Now let us see what they are talking about. Read committed, read uncommitted, and repeatable read is available. What is repeatable read? Can you please read this point? Repeatable read.
Dirty reads are prevented.
Yes. Ensures that when the transaction is reading a row, then subsequent reading also will return the same data, not the other. That means you are reading one row, but other transaction updated that row, so you will not get that data. It is going to read the same row again and again. Ensures that if a transaction is reading a row, then subsequent reads will return the same data, preventing non-repeatable reads. Repeatable reads, same data you are reading. Serializable, strict isolation, guys. So ensuring complete isolation from other transaction, it can lead to decreased performance due to locking. Isolation means whatever the data that is committed, we are completely making sure that one transaction is not affecting other transaction. Every transaction will have its own isolation when you go for serializable isolation level. See here what they are saying about serializable isolation. A constant indicating that dirty reads, non-repeatable reads, and phantom reads are prevented. This level includes that prohibitions further prohibits the situation where one transaction reads all the rows that satisfy a condition, second transaction inserts a row that satisfy a where condition, and the first transaction rereads the same condition, retrieving the phantom row in the second read. Isolation means the transactions are independent. One transaction will not affect the data available in the another transaction. The strict isolation levels we are going to get when we with the serializable isolation concept. So transaction isolation having 4 values and the transaction propagation is having 6 values. Propagation types and isolation levels. So when these transaction propagation and isolation concepts are required, when we are dealing with calling methods and called methods, then we are going to talk about this. So here at the rate transactional we are going to specify and we will specify rollback for exception dot class. Whenever any exception occurred, then immediately I want to roll back the transaction. Okay. So when to go for a propagation and when to go for isolation, guys? In which scenario we should use propagation? In which scenario we should use isolation in the transaction? Propagation and isolation, when we need them. What is propagation and what is isolation? What is propagation and what is isolation? Come on. What is propagation and what is isolation, guys? No response.
Isolation is specifically for the visibility of the transactions.
Isolation is basically to deal with the visibility, how one transaction data is visible to another transaction.
Yes.
What is propagation?
Propagation is for the specific for the actions. What one method does for the it is subsequent for sub methods.
Yes, whether you want to reuse the transaction or you want to recreate the transaction, that will be defined by propagation. Okay, guys, this transaction nodes I'm updating in the data JPA only. This is related to JPA concept, guys. So you can refer this transaction nodes as part of data JPA. I'm updating the nodes in the data JPA. Yeah, data JPA nodes is updated in the website. So if you open our data JPA nodes, then you can see the today's concept, that is transaction management. How to roll back the transaction, what is the propagation, what is isolation, what are the propagation types available, what are the isolation levels available, that I have given in this JPA nodes. Okay, good. Fine, guys, thank you.
I was having a doubt, sir.
Yeah.
In propagation.
Yeah.
Can you scroll the screen, sir?
1 minute. Yes.
In the types. Yes, sir. So, like transaction means a particular flow or a process from one method to another method, right, sir?
Correct.
So, like supported means definitely there will be a particular process or transaction existing.
Correct. If the method is having the transaction, use it. Otherwise, it will try to execute now. Suppose, for example, we are having read operation. For the read operation, transaction is not required. Only for DML operations, transaction required. For DQL operations, transaction is not required.
Okay. Okay, for read, it is not required.
No.
And for like update, delete, or creation, insertion, it will be a.
Yes, we need transaction. For read operation, for select queries, transaction not required.
Okay. And the like in the isolation, the repeated one, repeatable, like exactly where we can use it. This one.
We don't, I never used it, sir. This is just for its topic purpose. It will, whenever one transaction reading a row, another transaction modify the row, but we are going to read the same row. We are going to read the old row, not the updated row. That is a repeatable read. I never used this. I will use this one, read committed. So generally isolation always will prefer read committed. So we will prevent the dirty reads. Only we will read the data which is already committed to the database. That is the final data. I never used these properties in the project.
Okay, got it, sir.
This is just for knowing for the interview purpose. So if anybody ask you, tell them I know what are the levels and types available, but I have used only one, which is read committed.
Okay, got it, sir. So this video will be available for us also, no?
Yes.
JRTP batch one.
Yes.
Okay, sir.
Is there any cursor stability parameter, sir?
Sorry?
Cursor stability.
Cursor stability, no, in the JP I have not gone through that.
Okay, sir.
I need to see that once. What is that? I don't know.
Okay, sir.
Okay, fine guys, good. With this we are done for today's session. We'll meet again in the tomorrow's class.